Welcome to the project demonstration of transmission line fault detection using Arduino with Wi-Fi module along with Twilio SMS Alerts. So here we are using IoT feature which is used to send the message alerts to the registered phone number using the Twilio app. So instead of using the GSM module, we are using the Twilio app which is used to send the message alerts to the registered phone number like this. So there are the messages we are going to receive, the alert messages, and without using the GSM module. So they are getting from the Twilio SMS service provider. So here we are mainly monitoring the faults like open circuit faults between the R, Y, B phases, and when we are transmitting the power from pole 1 to the pole 3, so at the receiving section. And the next fault is short circuit fault. If the short circuit fault occurs, the line to line, that is the R to Y or Y to B or R to B, and if the short circuit fault occurred between the poles, so if it's a pole 1, pole 2, then the system will provide us the alert message on the LCD screen along with the buzzer alerts, and the respective phases will be isolated in order to protect that, and also sending message alerts to the registered phone number. So what are the phase fault occur like this? Okay. So that's like sent from Twilio or telecom. That's a B phase to ground faults at P to P3, and the next high voltage, low voltage faults along with R and Y phases mentioning the pole numbers. So same for the short circuit, open circuits, and line to ground fault also. If the line to ground fault occurred between the phase poles, the same will be identified and that will be displayed on the LCD screen and sending the same through the like Twilio service provider. And here we are using the potentiometers to control the voltages, that is the low voltage, high voltage faults. For that purpose we are making use of these potentiometers. Totally like faults are high voltage, low voltage faults, and short circuit faults, as well as open circuit fault, and also line to ground faults, line to line, line to ground, open circuits, high voltage, low voltage. And whenever the failed fault occurred, then the relays are used to isolate the power supply to these loads that will be representing the protection purpose. And here to send the message alerts to the Twilio, we are making use of this ESP8266 Wi-Fi module. So let us explain you the components wise. So the main processing brain of the project is Arduino Uno, which will taking care of input from these pole sections using the current sensors are placed on this one, and relays to isolate the power supply for controlling purpose, buzzer for the audible alerts, and this is the breadboard to distribute the 5 volts power supply throughout the system. And these potentiometers to vary the voltage to make the high voltage, low voltage fault. And this one is the ESP8266 Wi-Fi module to send the Twilio SMS alerts, and this one is the regulated power supply board which will take 230 volts AC inputs and provide as a 5 volts DC output. So these are all about the project input output modules along with the features. So let us see demonstration. Before demonstration, the very first step is we need to on the hotspot. By using the hotspot only, the system will send the alert messages. So for that, configure the hotspot name to project 7288 without any space, without any capital letter. Password should be 129 and AP band should be 2.4 gigahertz. After enabling the hotspots and data, now you can on the circuits. Right. Now you can on the power supply to this one. So once installation successfully done, everything is normal. The bulbs will be on state, and also we can see one device is connected in your mobile phone, as we have on the hotspots and data and off the Wi-Fi. Right, everything is normal. Let us check with low voltage. Let us check with initial, as we discussed, voltage fault. So everything is normal now. Just I'm increasing the voltage of B phase. You can see the voltage is increasing slightly. Right, when it is crossed 240 volts, then automatically high voltage occurred, and the system will sending the message alert to the right. We got it. So sent from Twilio. So high voltage in B phase. Now again we set it low, normal. And decreasing voltage when it is below 180 volts, then low voltage, as already B phase got off. So when it is voltage settled to normal, then in order to resume the power supply to the respective phase, we need to reset the Arduino Uno. So instead of making auto resets, so in electrical, when the high voltage dealing with the fault rectification, then we are not supposed to do the auto reset, because while we are doing repair over here, so if it is normal, then automatically if the auto reset was done, then the person who is ripping over here, so will get the shock, means he is getting the high voltage. So to get the resume the power supply, then we need to reset the system. So again it will be coming to the normal. Again high voltage at R phase. So right, so we got high voltage in R phase. Right. Okay. Then to resume the power supply to the phase. Same for the Y phase. Again, we're making the low phase fault. High voltage in Y phase. Low voltage in Y phase. Normal now. Okay. And now let us check with short circuit faults. So between P2 and P3 pole numbers between R and. So we touch over there, automatically the two phases will be off, and we'll get that RY phase fault, line to line fault, that is P2 P3. Same thing on the LCD display. So now let us make the faults between P1 and P2. So R and B phase. So we made the fault between R and B phase, and again just keep on sending the message alerts. Right. So YB phase fault at P2 P3. YB at P2 P3. And now let's do the ground operation. So the ground we are using over here. Right. Now again, after reset, everything is normal again. We made the faults for P1 ground. So we get that R phase, P1 and P2. Again checking with right B phase at P1 P2 and same message alerts. B phase ground fault at P1. Ground fault P2 P3. So this is P2 and P3. So this is the ground fault along with poles identification location. And next check open circuit fault. Open circuit faults. Now let's check. So we got open circuit directly. It will fault occurred at Y phase instead of telling the pole number, because we are checking directly open circuit faults. So B phase, same alert open circuit fault in B phase. Right. Open circuit fault in R phase. So we got the message. And normal. Right. So this is all about the line to line fault, line to ground fault, along with open circuit fault in the high voltage, low voltage fault, along with location identification with respect to the pole numbers, and with Twilio SMS alerts.